Awesome. Well, I'm excited to be here today to talk to you all a little bit about the power of open source, which I haven't heard anybody mention open source so far this morning. I guess I shouldn't be too surprised, but thanks for laughing. And more specifically, the role that the Open Compute Project plays in applying the principles of open source to the hardware space, to really open things up, give consumers more control over the destiny that they have in their physical infrastructure, and do things more efficiently and more effectively, and really move forward the pace of innovation as quickly as we can. I think we all are leading more and more connected lives. I know I don't have my smartphone with me right now because there was going to be some interference issue, and I feel a little naked without it. I see most of you are online right now. Knowing that the water is flowing is always good, but I don't think we always think about the source of the water or the plumbing behind it. And that's one of the things that the Open Compute Project really does, is bring light to that area. So just to put that into context, as we think about our ever-connected lives, the millions of people and the multiple millions of devices that are coming online, and the weight that that puts on the infrastructure, if we don't do something differently, it is quite possible that the closed and proprietary approach to technology development will be the limiting factor in the way we scale the internet, in the way we deliver awesome experiences to people. And so open source has clearly had a huge impact in the pace of innovation in software, and it's starting to have that same impact in hardware as well. So just to put that into context, we'll just talk about data growth just for a minute. And this ignores CPU horsepower, network bandwidth, all the data center construction energy that goes into powering the internet. Just data alone is just the example that we'll talk through here for a minute. So I'm not going to talk about all the ones and zeros and read this chart to you, but this is some data from an IDC study that shows how rapidly data is growing. About 800 exabytes of data were online in 2010. In 2012, that number had more than tripled. And we're on a pace that by 2020, we're talking about 40 zettabytes of data online. So I'm kind of a physical guy. I like to touch and feel physical infrastructure. So to put this into context, I had to think about it in terms of number of disk drives. So how many of you are familiar with the size of like a 3 terabyte disk drive? It's about 6 inches long. Well, it'll take about 13 trillion of those disk drives to store 40 zettabytes of data. And that's about 1.3 million miles long if you put them end to end. That's about 2.5 round trips to the moon. So if we continue down the path that we're on, we're going to have huge piles of disk drives, right? And as most of you know, the areal density on disk drives is starting to flatten out, right? We don't need 3 terabyte disk drives, we need 3 exabyte disk drives, right? Something's got to change here, and I think the power of open source applied to this problem can help us move forward faster. So that's obviously a lot of gear. Where we put all that gear is in data centers typically, and this is actually a study from the Uptime Institute just to show kind of the delta between the kind of the normal way, the industry standard way of doing data centers, and the open compute approach that we've shared through the project. There's a metric in the industry called PUE, or power utilization effectiveness, that measures essentially how many watts you have to take off the utility pole to deliver a watt to the server. Unfortunately, the industry average right now is about 1.9. That means you're pulling almost twice as much power off the utility pole as you need to deliver it to a server. That's crazy, especially given the fact that a lot of the electricity, especially in the United States, is coal-generated electricity. It's not good for the environment. Why all that waste? Well, I mean, you take very high voltage off the utility pole, you transform it, you typically put it through an online UPS system, you convert it to DC, back to AC, then you step it down to 208. You run air conditioning. I'm not sure why servers need to be as comfortable as humans. And why do we air condition the heck out of our data centers? I don't know. They should probably hand out jackets before you go on some data center tours. But that's where all this waste is coming out. With the open compute approach, now again, we had the opportunity to start with a clean sheet of paper and rethink everything from the utility pole down to the server. The end result of this approach, by taking high voltage, never passing it through the UPS system, never running an air conditioner, delivering relatively high voltage directly to the device, is a much smaller amount of waste. So we basically pull 1.07 watts off the utility pole to deliver a full watt to the server. This has a tremendous impact. This was, just for Facebook, this was about a 38% operating cost advantage for us relative to the co-location sites that we were in. It was a huge advantage. And also, by eliminating a lot of that stuff, you eliminate a lot of CapEx expense as well, about a 24% CapEx savings by taking this approach. So, this is where the Open Compute project comes in, right? Number one, we don't want technology or the availability of the back end of the infrastructure, the plumbing, so to speak, to ever be a limiting factor in the richness of the experience that we can provide. I was just thinking about this morning's keynote about all the devices and all the data we could create, even on a basketball court, for example. I mean, there's going to be a tremendous, for every person that comes online, there's multiple devices that are coming online, and then the richness of the experience that we want to provide. We don't want technology to ever be that limiting factor. There are a lot of great technology companies, but there's no greater technology company than a community of smart people that come together to move things forward fast. So we got to do it right so that we do things not to slow down the user experience, and we certainly don't want to struggle to implement things in a way that's bad for the environment. So I'll just give you all a quick history of the Open Compute project. This started as a Facebook project. So when we saw the growth of our business, we saw the cost and complexity of scaling through leased data center space, off-the-shelf servers and storage. We knew we had to take a different approach. The end result of that, as I mentioned earlier, 38% more efficient, 24% more cost-effective. The first summit was kind of at Facebook headquarters. We were the first company to contribute technology to the group. About 200 people showed up. It was clear at that time that there was a lot of pent-up passion in the end-user community. The end-user community was pretty frustrated with trying to influence vendor roadmaps to get what they needed for their particular environment. So we hosted another summit in October in New York. And actually, what pulled us to New York were a lot of the financial services companies who also happened to be very early adopters of Linux and saw the opportunity to apply those same principles to the hardware space to move their environment forward faster. We also decided that this was a community project, not a Facebook project, so we spun this out into a nonprofit foundation. We launched this as a consumer-led. You'll notice that the board of directors is primarily consumers. We also have Jason Waxman from Intel and Andy Bechtolsheim as well. Then, luckily, since we are a nonprofit organization, Rackspace let us use their headquarters in San Antonio. We had a great summit there. We introduced a new rack standard called OpenRack, which really defines a new hardware API for the mechanical and the electrical interfaces for the devices that go into the rack. We also had large-scale providers like HP and Dell demonstrate OpenRack compatible designs at that time. And just past January, we had our 4th summit in Santa Clara, and as you can see, attendance has now tripled. About the number of people that are here at this event. We have over 50 official members, both from the consumer side as well as the supplier side, and dozens of technology contributions. And I think this is the part that I'm really the most excited about, are the contributing members to this foundation. So traditional technology development companies, which I used to be part of one. I grew up in the hardware industry, and you work on projects, and you typically don't even tell your parents or your friends or your family about what you're working on. And we're seeing examples now of technology companies thinking differently and actually contributing technology to this effort in the effort to move things forward faster. So this is just a quick snapshot of some of the membership of Open Compute. And as you can see, things are really taking off, not just here in the US, but also worldwide. We just launched Open Compute in Asia Pacific. We have membership from Europe. We have a strong group of suppliers and a strong group of consumers as part of this organization. So just to summarize, what we're building here with Open Compute, first and foremost, it's consumer-led. I think historically, hardware suppliers especially have underestimated how much customers know about their infrastructure and how much control they desire to have over what they want. So first and foremost, Open Compute is consumer-led. We play an important role, I think. This isn't, people always ask, well, what's the impact of this to the incumbents? And this is either the greatest opportunity for the incumbent, or it's the greatest threat to their business, depending on whether they embrace it or not. Second key point is this is 100% merits-based. This goes hand in hand with open compute having no pay-to-play model. Many of these foundations have an opportunity for people to become a member, they pay a bunch of money, then they get a vote on the board. This is always going to be a merits-based project. This will be led by the consumer's voice, not by the commercial interests of technology suppliers. There always has to be a balance there, right? That's why our community includes both. But I think customers know what they want, and we just want it to be built effectively and efficiently. There's opportunities to make money in open source. We just have to think differently about how to do it. We're going to stay focused on scalability and efficiency and sustainability. We've had many, many requests from people all around the world of, hey, this is really cool. You're applying open source principles to the hardware space. I acquired this technology for electric cars, and I'm frustrated by the fact that people are putting up proprietary charging stations. Maybe we could start something there. That's interesting. That's awesome. I'm flattered that they came to talk to us about how to set that up. But that's pretty far afield from what the Open Compute Charter is. It's focused on data centers, servers, and storage. And last but not least, we're going to design and deliver in the open and continue to do that. Right? If you look at the first version of the Open Compute designs that Facebook contributed, these are tangible products that people can see and touch and feel. We're not going to pontificate and build wish lists and beg the supplier base to build something for us. If the supply base won't build it, we'll just build it ourselves. So I mentioned the impact of open source. It's clear the impact that it had in the software area. And now let's see what's happening in the rest of the data center stack. So we'll play a little open source bingo here, if you will. Clearly, what inspired us is the green part of this chart. Right? Open source software has caused things to move forward very, very quickly. People can branch, people can build things the way they want to build things. But traditionally, the hardware environment has not moved forward very quickly. It's only moved forward as fast as one technology company could move it forward. Enter the Open Compute project. One of the first things we shared was the optimizations that we had done within our co-location facilities. Because people were like, hey, this is great that it's for scale computing, but there's only like 5 big guys out there, and not a lot of us are buying real estate and breaking ground on new data centers. So we said, well, neither were we back in 2009, right? We did a lot of things in our co-location facilities, everything the landlord would allow, and we've shared all of that to make the colo sites more efficient. We also, as I mentioned earlier, we've completely open sourced the greenfield data center designs, and we've seen some examples of customers following that lead. And the aggregate impact of building data centers like that on the environment is so much greater than any one company. And last but not least, I mentioned that 40 zettabytes of data. A lot of that's cold data. A lot of that is just, it's really hot. Photos would be a great example on Facebook. They're really hot for like 30 days. But after that, the tail on that falls off really, really quickly. So we've now shared also cold storage optimized at the facility level, right? Because if it's a replication copy, maybe that data center facility doesn't need to have as much reliability or resiliency in it, right? If it's offline for a little while, that may not be that big of a deal. So we've shared those designs as well. Then if you look at the rack layer, again, co-location sites. We didn't even think about sharing what we call the Ash rack. We have a co-location facility in Ashburn, Virginia, and when the community found out that we had actually developed a rack enclosure specifically for colos so that you could get the benefits of Open Compute servers in a colo site, it's become one of the more popular projects within Open Compute. And then, as I mentioned, Open Rack. This is really the first such standard that was actually a rack enclosure that's designed specifically to go into data centers. We also help demystify server design with 2-socket Intel and AMD servers. I think another great example of this is AMD's Open 3.0 motherboard. They co-developed this motherboard with Fidelity and Goldman Sachs, right? They were really passionate. They know exactly what they want in a system, and they've collaborated directly with AMD and also Intel to develop these boards. At the last summit, we introduced a motherboard we call Group Hug, which is, again, a standard hardware API so that we don't have to reinvent the wheel every single time we want to plug in a different SoC, right? The whole activity around ARM-based SoCs and x86-based SoCs, it can move forward so much faster if there's a common plane for all these things to plug into. And we actually demonstrated Applied Micro and Intel CPUs sitting on the same motherboard. So pretty cool ability to bring a common standard together, but still leave a lot of room for people to innovate on top. OpenVault, this is something else that we introduced. This is basically the design point is how vanity-free can you make a storage device, right? What we really care about in a storage device is the media that stores the data, right? Why is there all the goop, the technical term goop? Why all the goop around the disk drives, right? How can you eliminate all of that, make the device highly reliable, but also very efficient from the ability to service the device, right? When you think about whatever that number was, 1.3 or 13 trillion disk drives, being able to get to them and replace them when they fail is kind of an important thing. We've seen a lot of software activity around that project. So a lot of people that are building really innovative software are looking for an open platform to deploy it on, because they're not in the hardware business. They're in the software business. They're innovating in software. They want open source hardware to land it on. And then again, from a cold storage perspective, we did a slight derivative work off of OpenVault and optimized it for cold storage. So only spin up one drive at a time. Use really low-end kind of crappy media. Have it be really sensitive to rotational vibration or operational shock. So you can use extremely low-cost media for your cold storage environment. So you notice this strip along the top at the network layer. It's been immune, for the most part, from the impact, the positive impact of open source. But we're starting to chip away at it a little bit. At the last summit, we had a pretty awesome contribution from Intel around silicon photonics, so at the interconnect layer. This interconnect is going to be extremely high speed, extremely low latency. It is going to be part of the in-rack fabric that allows us to disaggregate system components and bring better technology refresh cycles and optimize the hardware to the software without having to go through multiple virtualization layers to do so. I also think there's a lot of great work happening in the Open Network Foundation, Open Daylight, bringing some level of openness to the SDN community. But unfortunately, the hardware in the operating system is still sold today as a black box. It's an appliance, right? If I buy a switch, it comes with an operating system embedded on it. Our vision is that this should be treated just like another server in your rack. You should be able to deliver a bare metal device, have a pre-boot environment on it, and download an OS to it. So I'm excited to announce that we are expanding the scope of Open Compute to include networking. The team is already starting to rally around this. The founding group so far are folks like Open Daylight, ONF. I think ONF saw the progress that we've made in data centers, server, and storage, and said, hey, what if you guys took a swing at the networking hardware space? Big Switch, Intel, Broadcom. This is just a short list of the people that are starting to come together around this project. The real work will start in earnest next week. We're going to have our first Open Compute Engineering Summit at MIT. I would encourage any of you who are interested in joining the project to please join us in Boston next week. I think it's Wednesday-ish. But that would be awesome. The more people that we can get to work on these really, really hard, complicated problems, the better. Because like I said, no matter how great of a company you are, you can attract a lot of the best engineers in the world, but until you open source something, you can't get all the best engineers in the world to work on a really tough problem, like the problem that we face in networking. So with that, I say thank you very much, and openness always wins. Thank you very much.
Thank you, Frank.